Wireless transmission. Wireless transmission is a form of unguided. Wireless communication involves no physical link established between two or more devices, communicating wirelessly. Wireless signals are spread over in the air and are received and interpreted by appropriate antennas. When an antenna is attached to electrical circuit of a computer or wireless device, it converts the digital data into wireless signals and spread all over within its frequency range. The receptor on the other end receives these signals and converts them back to digital data. A little part of electromagnetic spectrum can be used for wireless transmission. The electromagnetic spectrum. Radio transmission. Radio frequency is easier to generate, and because of its large wavelength it can penetrate through walls and structures alike. Radio waves can have wavelength from 1 mm, 100,000 km, and have frequency ranging from 3 Hz extremely low frequency to 300 GHz extremely high frequency. Radio frequencies are subdivided into 6 bands. Radio waves at lower frequencies can travel through walls, whereas higher RF can travel in straight line and bounce back. The power of low frequency waves decreases sharply as they cover long distance. High frequency radio waves have more power. Lower frequencies such as ELF, LF, MF bands can travel on the ground up to 1,000 km over the Earth's surface. Radio waves of high frequencies are prone to be absorbed by rain and other obstacles. They use ionosphere of Earth atmosphere. High-frequency radio waves such as HF and VHF bands are spread upwards. When they reach ionosphere, they are refracted back to the Earth. Radio wave, ionosphere. Microwave transmission. Electromagnetic waves above 100 MHz tend to travel in a straight line, and signals over them can be sent by beaming those waves towards one particular station. Because microwaves travels in straight lines, both sender and receiver must be aligned to be strictly in line of sight. Microwaves can have wavelength ranging from 1 mm, 1 meter, and frequency ranging from 300 MHz to 300 GHz. Personal area network. Microwave antennas concentrate the waves, making the beam of it. As shown in picture above, multiple antennas can be aligned to reach farther. Microwaves have higher frequencies and do not penetrate wall-like obstacles. Microwave transmission depends highly upon the weather conditions and the frequency it is using. Infrared transmission. Infrared wave lies in between visible light spectrum and microwaves. It has wavelength of 700 nm to 1 mm and frequency ranges from 300 GHz to 430 THz. Infrared wave is used for very short-range communication purposes such as television and its remote. Infrared travels in a straight line, hence it is directional by nature. Because of high frequency range, infrared cannot cross wall-like obstacles. Light transmission. Highest most electromagnetic spectrum which can be used for data transmission is light or optical signaling. This is achieved by means of laser. Because of frequency light uses, it tends to travel strictly in straight line. Hence the sender and receiver must be in the line of sight. Because laser transmission is unidirectional, at both ends of communication the laser and the photodetector needs to be installed. Laser beam is generally 1 mm wide, hence it is a work of precision to align two far receptors each pointing to laser's source. Light transmission. Laser works as TX transmitter and photodetectors works as RX receiver. Lasers cannot penetrate obstacles such as walls, rain, and thick fog. Additionally, laser beam is distorted by wind, atmosphere temperature, or variation in temperature in the path. Laser is safe for data transmission as it is very difficult to tap 1 mm wide laser without